Hi everyone, I'm Ryan, and today I will be talking to you about the Fresnel lens, and then we'll show you a little demo using the Fresnel lens to capture the power of the sun and focus it onto various objects in order to burn and melt these objects. But before we get into the actual demo, I would like to explain the concept of refraction, and then what a traditional lens is, and then move on to what a Fresnel lens is and how this differs from what a traditional lens is. And so starting off with the concept of refraction, this describes the change in direction of light as it passes from one material into another. And so many common places that you'll have seen this before is with water. In the first case, we have a straw in a glass of water, and you'll have noticed that the straw in the air appears to be dislocated from where it appears to be in the water. Another place where you may have seen this is in a lake or in the ocean, where if you're ever looking down at a fish, its actual position is slightly below where it actually appears to be. Additionally, you may have seen at the corner of a fish tank, there will be kind of two images of a fish, but you know that there's actually only one fish there. And so why does this change in direction happen? It happens because light is faster in air than it is in water. And this is because the water molecules are going to be more dense, and as such, light traveling through the air will have to interact with less molecules that can actually slow it down. As a result, you'll have a faster speed of light in air than in water. And this results in a change in direction. And now, I know it's not as apparent why this change in direction happens, so I have an analogy to kind of help you understand that. And so, like a dog, light will take the fastest path from any 2 points. And so, if you're playing fetch with your dog and you throw your ball into a pool, like such, a lot of people would say that the fastest path would just be a straight line, like this one. However, this doesn't account for the difference in speed of the dog. We know that dogs are very great runners, but they are not very fast in the pool, as they have to doggy paddle their way. And so the actual best path, or fastest path to take, would be something like this, where you have a straight line to the pool, but you kind of change directions as you enter the pool. And that's because although the overall distance that this path is longer, the overall time it takes to traverse this path will be less, just simply because you're shortening the amount of time you have to spend in the pool where you're slower. And the same thing will kind of happen with light. And so that's why you observe this change in direction. And so lenses will use this refraction and take advantage of this change in direction in order to direct where light will go. And so if we start off with just a glass pane, we can see these are just a bunch of the different paths that light could possibly take. And so if we curve one of these surfaces, we can kind of control where this light is directed. And in this case, we've curved one of the surfaces so that all of the paths coming from this one point will move in the same direction after passing through our lens. And this is a little bit easier to see if we just take a look at one of these paths up close, where we get a refraction happening at the very first surface, and then another refraction happening as we get to the second surface. And so those transitionary areas between air and glass, and then from glass back into air, are where we get these changes in direction. And so the big idea, this is very useful in many different applications of where we're redirecting light. And so this, for example, a telescope is taking light from deep into space and kind of redirecting where this light is going in order for us to see it with our human eye. same kind of idea with magnifying glasses and microscopes, where you can kind of take light from something very small, such as a cell, and redirect the light so that you can see what's going on with your eye. Cameras will use lenses to take light from a scene and direct it onto a sensor so that an image can be saved and viewed later. Projectors, like the one projecting these slides up here, will take light and direct it so that it hits this projector screen and be visible. Also, a lot of spotlight illumination will use a lens to kind of send that big beam of light in order to highlight something that's happening on a stage. And also, the eye itself is a lens, and glasses are kind of there to aid your eye in the case that your vision isn't as well. So I have a little diagram here showing kind of how that works, where your eye acts as a lens directing light onto your retina, and then your retina will process that signal in your brain. And so what happens with nearsighted or farsighted vision is the light isn't exactly directed onto your retina. And so what glasses are doing is they are lenses which are designed to kind of help your eye focus that light onto your retina and make it easier to see. So moving on to what the Fresnel lens is. This is a lens that is thin, inexpensive, and also lightweight. So there's many applications which benefit from having this kind of design. And then we'll get into kind of how this lens can be better in these areas. And so starting from a traditional lens, this is the same diagram as before, showing the many different paths of light. But what you want to notice is that the changes in the direction of these paths actually only happen at the surfaces or the boundaries of this lens. So only at that first interface where you go from air into glass, and then at this second curved surface where you're going from glass into air. And so we don't actually need a lot of the thickness in order to actually bend these rays. And so what we can do is we take our traditional lens and we split it up into different segments. And these segments can then be made thinner. Each of these segments are thinner on their own, and then once we put them back together, we're left with a lens that is just thinner and uses less material, and therefore is less expensive. Here's just a diagram of how different light paths would move through a Fresnel lens, and each of these segments can contribute to directing each of these paths in a way where, same as before, we're directing each of these paths to move in the same direction. And so something else to point out is that these segments are actually rings if we look at it from the front view of the lens, and that's why we kind of get this characteristic ring shape of the Fresnel lens. And that's something that you can kind of identify if a lens is a Fresnel lens, is it'll have these rings. And the first use, which is a very great application of the Fresnel lens, is in the lighthouse. And the reasoning behind this is because in order to direct light out so that it can be seen by boats that are miles and miles off of the coast, you would need a huge lens in order to direct a lot of light. And as a result, you would need, with a traditional lens, you would need a lot of glass, and it would be very heavy to kind of carry up this lighthouse tower. But with the Fresnel lens, it will take away a lot of that bulk, so you don't need to pay for as much glass needed to produce a large-scale lens like this. You also are able to mount it much more easily. Carrying it up this tower is going to be a lot easier. And also, you don't lose out on, or you're able to direct a lot more light because you're able to make these lenses bigger. And so these Fresnel lenses are not just simply better than a traditional lens. There are cases where the Fresnel lens is better, but there are many cases where the traditional lens is better and that's due to the imaging quality. With a Fresnel lens, if you're trying to see an image through this lens, it'll be a lot harder because of the segmentation. You're kind of having to piece back all of the different light paths as opposed to just having a continuous surface where you'll get a clear image. And so the ideal applications of a Fresnel lens would be with illumination, where you don't necessarily care about an image, you're just trying to direct light onto something to make it easier to see. The same thing with lighthouses, you don't care about seeing the actual light source, you just want to be able to see light at very far distances. And also some projectors will use a Fresnel lens simply just because they are cheaper to produce. But there are many bad applications, such as in glasses. You wouldn't want to make glasses out of Fresnel lens because you really care about how clear your image is. Same thing with telescopes and microscopes, where you're really trying to study objects, and so you would want to maintain that image quality by having a traditional lens. And then with that, we'll move to our demo, where we direct light from the sun onto various objects with a Fresnel lens. And some things about safety before we move outside is we want to use goggles, protective goggles, to protect our eyes from the intense light, and then also avoid touching the objects after they've been directed light onto. Now we'll move outside for the demo. Alright, so we have our Fresnel lens here, and two things that we want to make sure is that we point the face of our lens directly at the sun, and then two, that we are at a correct distance from our object so that all of our light is focusing onto a small spot. So we have three objects here that we're going to focus our light on. We have just a leaf, a lava rock, and then a penny. And let's see what happens. Let's get to our lava rock. It may take a little bit to heat up. But we can see a little bit of the obsidian forming, melting our lava rock. And now we'll do the penny. This one may take a little bit longer to get it to melt. That's our demonstration with the Fresnel lens.